Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 8, boys and girls both wings, subject chemistry, chapter number 3. And this chapter is about the periodic table and periodicity of properties. This is my 19th lecture, and I am your lecturer, Mrs. Saira Jamal. Before going into the next topic, let us take a quick review of the previous topic, that was periodic table. As I told you that periodic table is composed of, you can see here, it is composed of different groups. The vertical columns in the periodic table are called groups, and the horizontal rows in the periodic table are called periods. Vertical rows are called groups, and horizontal rows or columns are called periods. As I told you that there are 18 groups in the periodic table, but 18, I told you that group 8b is classified into 3 subgroups. That's why total group are 16. Out of those 16 groups, 8 groups are called main group elements, and they are represented by the letter A. You can see 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. These are called main group elements, typical elements, representative elements, and main group elements. The B group element, as I told you that the group 8B, you can see here 8B is classified into 1, 2, and 3 subgroups, but we will consider it as a single group. So we have 1B, like 8 groups are main group and 8 are B groups. B groups are called transition metals. So you can see 1B, 2B, 3B, 4B, 5B, 6B, 7B, and these three are called 8B. So 8 A group elements and 8 B group elements. So total groups are 16, and those 16 are, I told you, divided into A and B groups. A group elements are called main group elements, typical elements, representative elements, main group elements, while the B group elements are called transition metals. So the columns in the periodic table are 18, but we'll consider those two groups, like there are, I told you 8B is classified into 1, 2, 3 columns. So we will consider these 3 columns as a single column. So 1, 2, 3, 4, 5, 6, 7, and these 3, 8. So total 8 B groups are there. So 8 main group, 8 transition elements or B groups. So 8 plus 8 total are 16 groups in the periodic table. The first group has a specific name, alkali metals. And I told you why are they called alkali metals. They are called alkali metals because the oxides and hydroxides of this first group element, they form alkalis when react with water, or they form bases when react with water, or they form hydroxides when react with water. The second A group or 2A group elements are called alkaline earth metals. They are called alkaline earth metals, same like alkali, because the oxides and hydroxides of group 2A also produce alkaline solution when react with water, and earth metal because they are abundantly present on earth crust. The group 7A elements are called halogens. Halos, I told you, means salt, and gen means former. So halogens are the elements of group 7A, which form salts when react with metal. So that's why they are called halogens. The 8th A group, which is the last group of the periodic table, These elements are called inert elements, noble gases, or zero group elements because they show no reactivity towards other compound. The reason is that they are highly stable and their outermost shell is already completely filled. And the last two, you can say, period which are assigned separate position in the periodic table. They are lanthanides and actinides, or they are called 4F series and 5F series, and they are also called inner transition element. These elements are called outer transition elements, and the lower two are called inner transition elements. Lanthanides are also called rare earth elements. They are also called rare earth elements. You can see the first one is called lanthanide series, the second one is called actinide series. Lanthanide series and actinide series, inner transition element, 4F series and 5F series. These are the different names for these groups and periods in the periodic table. Example 3.3, electronic configuration of atoms of some elements are given below. Place them into groups and periods, although we have done some of the examples in our previous lecture. So P1s2, 2s2, 2p2, 2 is the outermost shell, and n is equal to 2 means that it is present in period number 2, and 2 plus 2, 4 electrons are there. So 4 electron means that this P must be in period number 2 and group number 4. So period number 2, period number 1, period number 2, and group number 4 is here. So P will be placed here. This is the position of P. Position of P is here. You can see position of P is here. 2s2 means 2, n is equal to 2 means second period, and 2 plus 2, 4 electrons. So you know that the valence electron decide the group number. So 4 electron means that P will be in group number 4. Then Q outermost electronic configuration is 1s2, 2s2. This must be 2p1, not 3p1, because 3p1 is not possible. After 2s, the next orbital, according to the Abbo principle, is 2p1. So this is 2p1. So 2 is the, like, n is equal to 2. Q must be in second period, and 2 plus 1 electrons are 3, so in third group. So this is the position of Q, third group and second period, third group and second period. 2s2, 2p1, that must be Q. This must be Q, not Z. This must be Q. Then R is 1s2. 1s2 means the first uh, period, because n is equal to 1, and 2 means 2 electrons are there, so it must be in the second period, but this is an exception, second group, but this is an exception because 1s2, the first shell which has 2 electrons, and this shell is completely filled. This is only for the helium, so the R must be here, helium, because the outermost shell is completely filled. First shell is the outermost shell, and the first shell can accommodate maximum 2 electrons. So this is the correct position of this R. Then 2s2, 2s1 means second period and first group, T. 2s2 means second period but second group, and 2s2, 2p6, 6 plus 2 are 8. So 8 electron means 8th group, and n is equal to 2 means second period. And 3s2, 3p6, 6 plus 2, again 8 electron means 8th group, but the period number is 3 because n is equal to 3. The n value is 3. So this must be in third period. And then 3s2, 3p2, again third period, and group number 2 plus 2 electrons 4, so fourth group. And 3p1 is third period, and 1 electron means group number 1. So by this way you can assign the position to all the elements. From then n value will decide the period number, and the number of electrons present in the outermost shell will decide the group number. Blocks in the periodic table. The classification of elements in the periodic table, it is based upon the electronic configuration, the type of the subshell which receives the last electron of an atom determines the block to which that element belongs. There are 4 blocks in the periodic table: S block, P block, D block, and F block elements, and they are decided on the basis of the electrons which are present in the outermost subshell. You can see in this image that all the elements which are present in group number 1 and 2, they are called S block elements. You can see here the first period is 1s because it has one shell. Second period has 2 shells, 2s, 3s, 4s, 5s, 6s, 7s. The shell number changes, but the outermost subshell is S. You can see S, 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 S. So group number 1a and 2a elements are called S block elements, while the group number 3 to 8, from 3 to 8a are called P block elements. Again, the shell number changes. 2p means second, 2 shells, 3 shells, 4, 5, 6, and 7 shells are there, but the outermost subshell is P, 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 P. That's why from group number 3a to 8a are called P block elements. And then the B group elements are called, from 1b till 8b are called the transition elements. And again, the third period, so 3d, 4d, 5d, and 6d are the number of shells which are present with the d orbitals or d subshell, and the lower two are called 4f and 5f. They are called F block element. 1 and 2 are called S block element. From 3 to 8a are called P block elements. From 1b to 8b are called D block elements, and lanthanide and actinide are called F block elements. F block are 4f and 5f series. The first block, as I told you, are called S block elements. Why are they called S block elements? They are called S block elements because the elements in which the last electron enters in S subshell are called S block element, like 1s2. 1s2 means that the outermost subshell is 2 and it has 2 electrons. So it is called, as the outermost subshell is S, so they are called S block element. The elements of group 1a and 2a, as well as helium of 0 group or 8 group, is called S block elements, or they are called S block elements. Then same like the S block, the element in which the last electron enters in P subshell, like 1s2, 2s2, 2p6. So the last subshell is P. So those elements in which the last subshell is P, or the configuration stop on P subshell, are called the P block elements, and the elements from group 13 to 18. 3 to 8 or 13 to 18, except helium belongs to this group or to this block. Not helium, because electronic configuration of helium is 1s2. Its configuration stop at S subshell. So helium is S block element, while the rest of all are P block elements. The elements in which the last electron enters in the D subshell are called D block elements. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d10, 3d2 or 5 or 10. So as the electronic configuration stopped by the D subshell, So those type of elements are called D block elements. The elements of group 3 to 12. 3 to 12 means from 3 to 12, like if we consider this periodic table, so from 3 to 12, they are called transition elements, or they are called D block elements. So 3 to 12, or we can also call it the B groups. Like as I told you, in case of B, it is 3B, 3B, 4B, 5B, 6B, 7B, 8B, and 1B and 2B. But if you consider this, the other one table, so these are from 3 to 12. From 3 to 12 are the group numbers for D blocks. You can see 3B, 4B, 5, 6, 7, 8, 9, and 1 and 2, or 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we can consider any of the periodic table. So they are called D block element, and the elements in which the last electron enter in F subshell are called F block elements, and there are two series of F block elements, 4F and 5F, as I showed you. 4F and 5F are the F series, or they are called the F block elements. And F block elements are also called inner transition element. D block elements are also called outer transition elements, and the F block elements are also called inner transition elements. Valence shell electronic configuration and position of an element in periodic table. You can determine the valence shell electronic configuration of an element in the periodic table, like from the period number of the element and from the n value, like n value or period number are same, and from the number of electrons which are present in the outermost shell. We can identify the electronic configuration of an element. In the previous example, we have done the electronic, we have done the identification of position of an element from the electronic configuration, but over here it is reverse. From the position or from the period number and from the group number, we will identify the electronic configuration of element. Totally the reverse of the previous examples. So as the first example is for the phosphorus. Phosphorus is present in the period number 3. So it means n value is 3, and as it is present in phosphorus is present in group number 5. So group number 5 mean, and the third shell means that the third shell mean it has 3s and 3p subshells, and 3s has 2 electrons, and p definitely will have 3 electrons. So 3 plus 2 will give us 5. So the group number of phosphorus will be 5. Valence electrons will be present in 3s and 3p subshell. The group number is 5. So there are 5 electrons in the outermost shell, and from this information now we can write the electronic configuration of like phosphorus, which is at 3s2 3p3. 3 is the period number, and 2 plus 3 5 electrons are the group number. Then example 3.4, obtaining the position of elements in the periodic table from electronic configuration. Now it is same like the previous example. For nitrogen, atomic number of nitrogen is same, configuration is 1s2, 2s2, 3p, 2p3. So the n value is valence shell electronic configuration is this. L is the outermost shell. You will write the L value. N value is 2, so period number is 2, and group number 3 plus 2 total electrons are 5. So nitrogen is present in the second period of group 5A. Oxygen atomic number is 8, and configuration is 1s2, 2s2, 2p4. So last shell configuration or valence shell electronic configuration is 2s2, 2p4, N value is 2 and total number of electrons are 4 plus 2 equal to 6. So oxygen is present in the second period of group 6A. Self-assessment exercise 3.4 is your assignment, same like this question, and is very easy. Society, technology, and science. As I told you that the periodic table which we are using now is called the long form of the periodic table, or also called modern periodic table. But before the modern periodic table, I told you that some scientists, they developed their own periodic table. One of the periodic table was Newland periodic table, and Newland periodic table was based on Newland's law of octave. So in 1864, John Newland, he was an English chemist, and he arranged 24 elements in order of increasing atomic masses, not in order of increasing atomic number. The modern periodic table, all the elements are arranged on the basis of their increasing atomic number. But Newland in 1864, he arranged all the 24 elements which were discovered in his time. He arranged all those 24 elements in order of their increasing atomic masses. And he noticed that every 8 elements starting from any point has similar properties. Few rows of his arrangement are shown below, same like the modern periodic table, because after 8 elements, the properties are repeated. So the table is like some of the limitations of the Newton law of octave are that his scheme, however, failed. Although he arranged 24 elements in some groups and periods, but his scheme, however, has failed because many elements were found out of place in his arrangement. He placed titanium with carbon and silicon, but the properties of titanium was different from carbon or silicon. Then he placed manganese in with nitrogen and phosphorus. So manganese is totally different from nitrogen and phosphorus. He placed iron with oxygen and sulfur. Iron is totally different from oxygen and sulfur. So due to these limitations, or this, you can say the limitation or drawbacks, this periodic table failed out. However, his arrangement of elements in order of increasing atomic masses formed basis for later classification of elements. Like the other scientists, then they took help from the Newton law of octaves. Then another scientist named Mendeleev, he presented his periodic table, which is called Mendeleev periodic table, and he was in 1869 a Russian chemist. Mendeleev arranged the known element. In Mendeleev time, 63 elements were discovered. So he arranged all those 63 elements in order of increasing atomic masses in horizontal rows called period and vertical columns called group, same like which we are using. The modern periodic table has many similarity with the Mendeleev periodic table. So this arrangement of element was called periodic table, and he stated his work in the form of law. Mendeleev periodic table was based on the Mendeleev periodic law. What is Mendeleev periodic law? Mendeleev periodic law was that properties of elements are the periodic function of their atomic masses. The modern periodic table says that the properties of the elements are the periodic function of their atomic numbers, while Mendeleev in 1869 said that the properties of the elements are the periodic function of their atomic masses. So Mendeleev periodic table also failed out, although the modern periodic table presented by Moseley, he took help from the Mendeleev periodic table, and that helped him a lot. Shape of the periodic table, or how are periods formed in the periodic table. You know that the horizontal rows in the periodic table are called periods, and the vertical rows are called columns. And there are 7 periods in the periodic table. So we will discuss some of the period. The first period, you know, it is composed of hydrogen and helium. You can see the first period is composed of hydrogen and helium. Only 2 elements are present in the first period. Elements are arranged in order of increasing atomic number. First period contain only 2 elements, hydrogen and helium. Both these elements have valence shell electron in their K shell. You know that K shell is the first shell, and first shell can accommodate only 2 electrons. So hydrogen has only 1 electron that will be present in the first shell, and helium has 2 electrons which will be present in the first shell. And you know that first shell cannot accommodate more than 2 electrons. That's why the first period start from hydrogen and ends at helium, because the first shell is completely filled now at helium because 2 electrons are there. Second period, lithium atomic number 3 has one electron in L shell. L is the second shell. So you know the second shell can accommodate 8 electrons. So second period begin with lithium. Since L shell can accommodate 8 electron, you know, second shell can accommodate 8 electron. So lithium has only 2 electrons in the first shell and only 1 electron in the last shell. So as it has only 1 electron in the last shell, that's why it is present under hydrogen in periodic table, because I told you that all the elements which are present in same group, they have same valence shell electronic configuration, means they have same electrons in their outermost shell. Hydrogen has 1 electron in the outermost shell. Lithium, sodium, potassium, rubidium, cesium, and francium. All of these elements, they have one electron in their outermost shell. Their valence configuration is totally same. That's why they are assigned same position in the periodic table. Not only for group number 1, group number 2, all the elements have 2 electrons in their outermost shell, then 3 has 3, then 4, 5, 6. All these elements, they have those number of electrons in the outermost shell, same like their group number. Second period start from lithium and ends at neon, because second period also can accommodate 8 electrons. The first period, I told you, first shell can accommodate 2 electrons, and the second shell can accommodate 8 electrons. So it will stop at neon, because neon has configuration 2s2 2p6. 6 plus 2 are 8. 8 electrons are already present in the outermost shell of neon, and it means that the outermost shell of neon is completely filled. N is equal to 1 is for the first shell, which can accommodate 2 electrons. N is equal to 2, second shell can accommodate 2 electrons. Third shell can accommodate, 8 electrons. Third can accommodate 8 electrons, and fourth can accommodate 18. Third can accommodate from 8 till 18 electrons, and N can accommodate 32 electrons. You can see that when in second period, if you see, we start from lithium and is present in group number 1, so it has 1 electron. This dot shows the number of electrons. It has only 1 electron in the outermost shell. Beryllium has 2 electrons in the outermost shell. That's why it is present in group number 2. And period number 2 means that the last shell is in all these elements. The last shell is second shell. So in the second shell, in case of lithium, has only 1 electron. Second shell has 2 electrons, 3 electrons, 4, 5, 6, 7, and 8. Now the second shell has 8 electrons, and second shell cannot accommodate electrons more than 8. That's why the incoming element will go to the next group, and the next group is same group, that is sodium, and it is present in group number 1. It is present in period number 3. All these elements has 3 shells, and the third shell can also accommodate 8 to 18 electrons. So 8 electrons, 1, 2, 3, 4, 5, 6, 7, and 8. That's why at argon the configuration stopped out, because 8 can accommodate, the third period can accommodate maximum 8 electrons. So 8 to 18 electrons, but 8 electrons in this case. So it means that they are following the valence electrons are according to their group numbers. Third period, next element, sodium has valence electron in the third shell, and third shell is M shell, and M shell can accommodate, I told you that KLM. K can accommodate 2 electrons, L can accommodate 8 electrons, and M can accommodate electrons from 8 to 18. And in sodium, valence electron is present in 3s. So 3s means 3s1 means as one electron is present in the outermost shell. So it must be in group number 1. Electronic configuration as lithium 2s1, so it comes under lithium. Magnesium with 3s2 valence electronic configuration come under beryllium, which is 2s2. S2 means 2 electrons are present in the outermost shell, so it must be placed in second group of the periodic table. Similarly, next 6 elements, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, on the basis of similar valence electronic configuration, come under boron, carbon, nitrogen, oxygen, chlorine, and neon, respectively. Argon has 3s2 3p6 valence electronic configuration, which means the outermost shell is completely filled. And the fourth period, next element, potassium, has 4s1 electron. S1 means 1 electron in the outermost shell, so present in the first group. And the last, and then after potassium, which is similar to sodium 3s1, so potassium comes under sodium in a new period. 4 begins with potassium, started with potassium. In this way, elements having similar valence electronic configuration come in the same group. The arrangement of element into period and important consequences, the element that have similar properties end up in the same group in the periodic table. Periodicity of property, the electronic configuration of the element shows a periodic variation with the increasing atomic number, periodic variation, systematic variation, or systematic change in their properties. Therefore, the elements also show periodic variation in their physical and chemical properties. Variation or change in atomic number means variation or change in their physical and chemical properties. Elements having similar valence shell electronic configuration have been placed in the same group, one below the other, as I told you. So they have then different properties. The atomic numbers are different, so they have different chemical properties. And what are the repetition in chemical properties? Chemical properties depend on the valence shell electronic configuration, because all the elements of a particular group have similar valence shell electronic configuration, and that's why they possess similar chemical characteristics or similar chemical properties. Periodicity in chemical properties depend on the valence shell electronic configuration, because all the elements of a particular group have similar valence shell electronic configuration, and that's why they possess similar chemical properties. They have similar chemical properties. The reason is due to the same valence shell electronic configuration. The configuration is same. So dear students, I hope you understand this lecture, and inshallah the next topics we will discuss in our next lecture. Till then, take care. Allah.